they asked me about a specific feature, like, am I excited about this? I was like, I didn't even know that was a thing.
Yeah.
Right? Yeah. My name's Brian London. I am the director of engineering for Data Platform. All right, let me think about this. Our data team is split into two sub-organizations, analytics and data engineering. Analytics has an analytics engineering team that's responsible for business logic of pipelines, transforms, business intelligence. SeatGeek's data team is responsible for both internal analytics purposes, so our own optimizing marketing, finance, product analytics, and also analytics and data as a service and part of our product for our enterprise clients. SeatGeek's data stack is built heavily around Redshift as our core data warehouse. We use Looker on top of that for business intelligence purposes. And we run a ELT architecture. So our inbound data comes from Fivetran, from some custom integrations we've written, and from a tool that we built in-house called Druspa, which is a production database to data warehouse sort of copying tool. Once those tools land data in our data warehouse, we use dbt to perform our transforms and create the analytics friendly tables that are the ultimate destination of all of that data. Running a data platform team, really you're doing a good job if nobody notices you, right? The dashboards are updated, they have the right data, everything's on time, things are largely uneventful. Before Monte Carlo, the way we would find out there was a problem most of the time is one of the business users would post a Slack message saying that they're getting results that don't make sense. And we began looking for tools that would help us track down where our problems were, identify failures before people come in the morning and see that the data isn't updated, and began looking at initially at some of the open source tools, Great Expectations. That seems sort of very burdensome to implement. And in the process, ran across a blog post, I believe by Bar Moses, on this sort of new set of data observability platforms that were coming on the market. I reached out to a friend of mine at a venture firm, said, hey, it looks like there's a bunch of these companies who are kind of all raising A rounds right around now. Who do you like in the space? We're interested as a potential customer. And they gave me Monte Carlo's name. After seeing the product features, they were really the only one that looked like a real product at the time. Monte Carlo was just so far ahead of everybody else at the time. This is what, a year ago. It seemed like the clear market leader. So there's two teams that predominantly are in Monte Carlo, in the tool itself. Those are the data platform team and the analytics engineering team. One of the things that Monte Carlo has done is enable us to stabilize our platform. So in addition to identifying when there is a problem, it has also helped us to understand where problems are likely to occur, where things are brittle. And over time, we've invested effort into cleaning up our lineages, simplifying our logic. And so our ELT system is today considerably more reliable than it was before Monte Carlo. And one of the consequences of that is many of the types of errors that used to happen, which would fall on the data platform team, don't happen anymore. So data platform is not in Monte Carlo anywhere near as much as they were over the first, I'd say, 6 to 9 months. And a lot more has shifted to analytics engineering, which is using it more kind of operationally.
So my name is Kyle Shannon. I am a senior analytics engineer here at SeatGeek, primarily working within the data quality and accessibility of the data within the warehouse at SeatGeek. Our team, as the analytics team and the analytics engineering team, uses Monte Carlo to identify issues in the data quality from various different degrees, whether it's certain things not being refreshed on the timelines that we're expecting, anomalies for dips or increases in the data that we're seeing, and using the tool in order to inform stakeholders of data downtime or data incidents that we are resolving. Monte Carlo helps us to root cause these issues. Essentially, inside the incident queue, we can see directly what was impacted, also see the downstream, right, to immediately understand the impact, but then actually root causing because of the lineage and understanding what models are leveraged into each other. We can easily trace through and see ultimately what area started the impact or started the issue, and then dig deeper right away into there instead of having to try and guess and query through the entire lineage to understand maybe where the impact started. Sure. One of the issues that Monte Carlo was able to help us resolve are, well, some of the most important ones are essentially the ones that we don't have visibility into. So unknown issues. There was an example of a data source that we did not have control over that's coming from third parties that had some anomalous data that we would not have had full alerting on when a schema actually changed and ultimately broke pipelines. Essentially, Monte Carlo was able to identify there was the schema change and that shift in data would be breaking that pipeline, and we were able to resolve it. So the ability to proactively see changes or shifts within that data is going to be helpful, especially if it's something that we're planning to implement or integrate into existing data visibility. Being aware of any issues that are happening ahead of time and understanding if this is something that we can use as a reliable data source for a future product before we actually are investing heavily into it. Detecting and resolving those incidents is typically within the hour that we're noticing. So we're getting alerted right away with much clearer guidelines as to where the root cause issues are so that we can immediately jump into notify stakeholders and resolve those issues faster. There's a few features that we rely heavily on that we like, and we rolled them out over time. So the first feature that we really dove deep into was the field health. And what that ends up doing for us is providing visibility on our tables of highest importance. So it'll show us any sort of shifts in any of the anomalous dips or movement in the data of tables that we are heavily relying on for our KPI reporting. An example being around marketing, if there's some sort of changes in return on ad spend, being able to understand some of those different distributions and or dips or anomalies that are happening on the underlying data so that we can get directly to a root cause and understand if it was a data ingestion issue or if it's actually something in the model that we're not accounting for. When you're looking into a root cause issue, you may see something that ultimately looks like a potential issue, but maybe it's related to something else. So having the full picture and understanding all the different moving parts of potential data incidents gives us more clarity as to where we can be digging into, as opposed to a potential issue that arose that maybe looks like it's related to this one issue that was on a specific alert. Now we actually have more of a full picture to understand. Beyond that, we then moved into the Looker integration, which has been great. Being able to understand from those dips or anomalies that we're seeing, how is that actually impacting the downstream consumption within the BI tooling? So this way we can proactively reach out to our stakeholders to make sure that they're aware that there's an incident that we're taking care of, and this is what's going to be impacted on the reporting for their end. So those were kind of the two immediate fixes right away. And the areas that we've been putting in more recently are around the schema changes, which I talked about in the previous example of being able to identify that there's going to be an issue with the pipeline due to a schema change, and the DBT integration, which is allowing us to trace our issues more directly to our data modeling itself and be able to identify root causes directly inside of our code to make adjustments as needed. Sure. So we leverage the Monte Carlo DBT integration to be able to pull in the actual run results from our DBT project. We are using DBT Core. We are moving all of the data from our run results into Monte Carlo as the runs are being performed. And then we also bring our catalog as the manifest into Monte Carlo as well, which leverages the tagging structure that we've set up to identify not only which models are highest priority, to be able to know how quickly we should be reacting to certain incidents, but also to understand the stakeholders and kind of domain that is impacted by the actual modeling itself. Yeah, leveraging Monte Carlo to identify these issues has made really everyone more efficient when it comes to debugging. As far as the amount of people that would be involved in an incident, there previously may have been 3 to 4 people having to look into certain areas, where now 1 or 2 people on the team can more quickly identify root causes without having to reach out via Slack and spend more time kind of going back and forth on debugging. So it's greatly improved the amount of people that are involved in incidents. So we have implemented at SeatGeek the monitors as code for Monte Carlo directly in our CI and CD pipeline. So as we are making changes to our DBT models, we implemented the YAML for our actual monitors that we want to be putting into different pieces of code as we're deploying it. And that directly integrates into Monte Carlo on our deploy so that we are creating those monitors directly related to the code that we're deploying so we can keep our observability up to date. We're mostly excited about Monte Carlo's roadmap, the ability to have more of the improved incident IQ, as well as the high-level monitoring dashboards. We've seen a bit of what that could look like, and it's been really helpful to see a larger picture of what's going on for all the different incidents that are happening and being able to report and understand how our data is moving and changing over time. As well as just improved integration with DBT. So as that continues to build out, we'll have more and more information around our DBT project leveraged in with all the rest of our data as well. Yeah, so SeatGeek's analytics engineering roadmap is quite a lot of different angles that we're looking at, starting with the core keeping the lights on kind of scenario where we are improving our data approachability as we scale out as a company. So making sure that it's easy to find all the data you need, making sure there's better alerting and monitoring on the data quality itself to reduce any downtime, as well as improving our orchestration to bring that data faster to the end users. With that would be happening with a partnership in our data platform to leverage some streaming data as well and be able to access this data more in a real-time fashion and serve it out to other areas of the product as well as the business intelligence.
This is a tool that saves a lot of time and a lot of stress for people who are on the front lines of our on-call rotation. And it does so in a way that just additional staffing couldn't, right? It removes work, it doesn't replace work. Before Monte Carlo, full day outages were fairly routine. When things broke, they would take an entire day to diagnose and fix. Now things are fixed much more rapidly and additionally just break less often. So I said at the beginning, we had a goal to get from 10 failures a month to 3. The 2 quarters, not the quarter where we onboarded Monte Carlo, but the 2 after that, we were at 0. I would say to somebody evaluating a tool like Monte Carlo to think about not only the effect it has on your immediate response to detect and resolve errors, but also how it makes you think differently about your pipelines and is going to be helping you improve those over time to improve their stability and reliability.